Hi, Kinesiology 3010. Welcome to our part 4 lecture of our inferential statistics. Today we're going to talk about independent t-tests, go through the calculation process, and you'll have an example problem at the end to calculate. Okay, so we use a t-test to compare the differences between two groups of independent nature, or they're not influencing each other. So males, females, children, adult, control, placebo, and a control or placebo and experimental group, two groups that are completely different in population. Okay, so like population A, say ones that are taught by the online method versus population B taught by the face-to-face method. So group A and group B. We don't know the population, the entire population, but we can take a sample of each. So sample of A and a sample of B. We're going to test those two samples against each other to compare them. The t-test is a comparison to see if there is a difference. So first step, state our hypothesis or null hypothesis. There is no significant difference in this example comparing the dependent variable to the independent variable. So that would be, in this case, there is no significant difference in those taught by the online method compared to the face-to-face method. Our research hypothesis or alternative hypothesis would be directional towards there is a significant difference in those who are taught by an online method and face-to-face method, or those in the online method will learn more compared to those in the face-to-face method, or vice versa. So in this example that we'll have for our calculation that we'll do together, there is no significant difference in cardiovascular endurance between long distance training and interval training between two groups of swimmers. So this was our example from a couple lectures ago. Step 2, we would need to locate the critical region or set the alpha level. So locate where on that table is our t statistic or our critical region. Okay, so locate where on that table we can say that we are 95% confident that we have found truth. Okay. Step 3, we determine our degrees of freedom for a t statistic that is an independent t-test. Our degrees of freedom is the population total of group 1 or population 1, sample 1, minus 1, plus population 2 minus 1. Because they are individual populations, they have individual degrees of freedom. To find the total degrees of freedom, we have to sum the degrees of freedom of each group. Okay, then we compute the t statistic using our t equation. We'll go through that in a little bit. And then make a decision comparing the t value against the tabled t value. So we have to compare our calculated t against the tabled t like we talked about in the part 3 lecture. Okay, step 5, we need to compare those with that critical region. If the t value is in the critical region, then we can reject the null hypothesis or say there is a significance. The t value is not in the critical region or not greater than absolute value greater than the t statistic in the table, then we fail to reject the null hypothesis. So there's not a significant difference between groups in that case. So our calculated t value must have an absolute value that is greater than the t statistic in the table based on the degrees of freedom and the alpha level. Okay, then we can create our conclusion if there is or is not a significant difference between groups. Okay, so when I said it was an absolute value, because we can have a significant difference where one is greater than the other in one direction or one is greater than the other in the other direction. You'll see what this means when we go through the mathematics. So if it's a greater absolute value, even if it's a negative value, if it's a greater absolute value, we can reject the null hypothesis. If it's greater in a positive value, we can reject the null hypothesis. The sign in the t statistic just tells us which group was greater than the other group. So if group A was greater than group B or group B was greater than group A, depending on how we set it up in our hypothesis and in our statistical equation. So what we're focusing on with the table is the absolute value of the t-statistic. Okay, so now how do we compute that t-value? Okay, we have some steps here. So first, we have to look at the sample difference. So we're looking at the differences between groups. We do that by comparing the means of the groups. So the mean of group 1 and the mean of group 2. So if I'm saying that group 1 is greater than group 2, I will put group 1 first. If I think that group 2 will be greater than group 1, I'll put group 2 first in my calculation. This helps to align the hypothesis with the t-statistic we calculate. Okay. Then we need to compare that to the population, because we know that when we're using our hypothesis testing, we're comparing against the population. Okay, so we need the population mean minus the population mean, or compare the population means. There's a key here. When we do this, we know with our null hypothesis that we are assuming no difference between groups or between population. So with that assumption, we can say that the population means are not different, or that that difference is 0. So this is key when it comes to creating this t-test. We have to have the null hypothesis in order to accurately calculate this statistic. Okay, then we need to pull in the variance, okay, the sample variance. So this is the variance of both groups combined. So this is a little where some of the math gets a little bit trickier. And then we have to get the estimated standard error, okay, or the standard error of that difference. So this tells us, based on the variance, how much error we are estimating is within this test. And then our t-statistic is our sample difference minus our population difference divided by our standard error of the difference. Okay, so we're saying that this difference divided by the error, the ratio of the difference to the error, will be greater than the t-statistic within the table. Okay. So the most difficult part is getting the standard error. The standard error is where most of the math comes in. Okay, so here's our standard error. It's the denominator of our t-statistic equation. So how do we compute it? Okay, we need to know the sum of squares. The sum of square, which the sum of square is our variance. Okay, we're going to use our variance equation here. Sum of square, variance equation, same thing. Okay, or a similar thing. Okay, this variance equation will tell us. So we'll back it up a little bit. Okay, to compute the standard error, we need to know the sum of square. Okay, the sum of square is the similar to the variance. So we have here is our sum of x squared minus the sum of x quantity squared divided by the sample size. So this is our sum of square. This is the denominator within our variance equation, okay, when we were calculating variance before. How we calculate it, we go through with creating our two columns, our x column and our x squared column, find the sum of x and the sum of x squareds, and we find our sample size, plug those into our sum of square equation. Okay, get our sum of square value, which in this case is 22. Okay, then we have to use the pooled variance, which is used to compute the standard error. This takes the sum of square of each population or each sample that we took. So the sum of square 1 plus the sum of square 2 divided by the degrees of freedom 1 plus the degrees of freedom 2. So we're creating a pooled variance based on the two different populations that we have and their degrees of freedom. So this is our pooled variance equation, or variance pooled. Okay. The standard error is the square root of the pooled variance divided by each population summed together. Okay, so we'll find our pooled variance, which is the sum of square of group 1 plus the sum of square of group 2 divided by the degrees of freedom of group 1 plus the degrees of freedom of group 2. We will then plug our pooled variance into our standard error of equation. So that standard error of equation is the square root of the pooled variance divided by the population size of sample 1 plus the pooled variance divided by the sample size of population 2. Those are each individual, and then we add them together and take the square root to find our standard error. Okay, so we just have to repeat that sum of square equation for both to get that information. So let's do an example here. Remember that our population difference is always 0 based on our null hypothesis. And then, as I said earlier, the direction or the positive or negative of the t-value depends on which variable we put first, which group we say is larger than the other. So we decide that based on our directional hypothesis if we think 1 is greater than 2 or if we think 2 is greater than 1. All right, so let's go through a full example. Say we have a psychologist who would like to examine the difference in verbal skills between 8-year-old boys and 8-year-old girls. Okay, the sample of 10 boys and 10 girls is obtained, and each child is given a standard verbal abilities test. Okay, so our population from 1 and our population from group 2 are both 10. The null hypothesis is that there will be no significant difference in verbal skills between boys and girls or between groups. Our alpha level is set at 0.05, and we calculate our total degrees of freedom, which in this case is 18 because group 1 minus 1 plus group 2 minus 1 gives us 18, or 9 plus 9. Now we use our table to determine what our degrees of freedom are. So we know that our degrees of freedom are 18, and with a p-value of less than 0.05, it has to be greater than our t statistic for 0.05 significance, which with 18 degrees of freedom is 2.101. Okay, so our critical value is 2.101, either positive or negative, depending on the direction that we see. Okay. So I'll give us the data for this study. We're not going to go through and calculate the sum of square together, but our population size, our means are 37 and 31, and the sum of square is 150 and 210. Remember, the sum of square comes from the sum of x squareds minus the sum of x quantities squared divided by the sample size. This done for each group gave us these values. Okay. So this has already been done for you, but make sure that when you're going through your example later on, you compute the mean for each groups, and then you compute the sum of square for each group. Okay, so we have now we need to find our mean difference. We need to find our group 1 minus group 2. Okay, in this case, it is 6, or group 1, which is girls, minus group 2, which is boys. Group 1 minus 2 is 6. So we're trying to see if this difference of 6 is a significant difference. Okay. If you flipped it around, if you said that boys would have a better score than girls or greater score than girls, you would have flipped these and you would have had a negative 6. So then you would have to focus on the negative t-value. Okay. Now we have to compute the pooled variance. Okay, the pooled variance comes from the sum of squares summed together and the degrees of freedom summed together. So we take our sum of squares, add them together, we get 360, and our variance, we get it together and it is 18. That gives us a pooled variance of 20. Okay. Remember, this has to be done in differences because sometimes our sample sizes aren't the same. Sometimes we'll have a sample size of 30 and 29, which will change that degrees of freedom for each group. There will be different degrees of freedom that we have to add together. Okay, so we know our pooled variance, we know the rest of our information. And now we have to find the standard error. So the standard error is the pooled variance divided by the sample size plus the pooled variance divided by the sample size for the second group. So we take those individual pooled variance, so the pooled variance, the individual sample sizes, add them together, take the square root, and we get 2. That gives us a standard error of 2. That standard error of that difference between groups is 2. Okay. We know standard error is 2. We know the mean difference is 6. So that gives us a t-statistic of 3. A t-statistic of 3. If we switched the groups, we would have had a t-statistic of -3. So now we need to make our decision. Okay, the alpha level is 0.05. The critical t-value is plus or minus 2.101. Okay, so we calculated 3. Okay, we have a computed t-value of 3 and a table t-value of 2.101. That computed t-value is greater than our table t-value. So what does that mean? That means that our conclusion is there is a significant difference because we can reject the null hypothesis. So it's larger on the positive, we reject the null hypothesis, there is a significant difference between scores. So remember our steps here for our t-statistic. Here we have our sample data or sample difference, our population difference, our pooled variance, our estimated standard error, and our full t-statistic. Okay, take these steps as you go through. It's going to help you if you make sure that you follow the steps the way that we just went through the steps. So now it's time for you to practice. Okay, this is our research question. Will group A run faster in the 10-meter sprint than group B? So what do we do first? Okay, first we have to find the dependent and independent variables. Okay, the research design, the statistical test, and then our hypothesis. Okay, so the dependent variable is what we measure. The independent variable is what we control. We control group A and group B. So independent variables are group A and group B. The dependent variable is the 10-meter sprint time. This is an experimental research design because we're trying to see the difference between groups. We have 2 groups. We're trying to find a difference, and they're different groups. So we'll use an independent t-test. Okay, now let's find our hypotheses. So our hypotheses are null hypotheses is there is no difference in 10-meter sprint time between group A and group B. Our alternative hypothesis is there is a significant difference in 10-meter sprint time between group A and group B. Either A will run faster than B or B will run faster than A. Okay, so now you'll practice. So what you need to do is calculate the mean difference between groups, the mean difference within the population, the sum of squares for each group, the pooled variance, the standard error, and the t-statistic. Okay, so these 6 values, and the difference between groups, so you'll have to calculate the mean first. Remember, you have to calculate the mean first before calculating the mean difference. Find the mean difference within the population. Hint, hint, we just went over how to find that earlier on. Find the sum of squares for each group. Your equation is available for you right here. On the pooled variance and the standard error. Okay. Here is the data that you're going to be calculating these from. So I have our data here. Here is our mean difference equation, population, pooled variance, our standard error, and our t-statistic. Okay, so write down these values, pause the video, write down these values. These are your practice, and you're having to find these 6 values. Okay. Once you've found these 6 values, I need you to compare your t-statistic that you calculated to the t-table based on the degrees of freedom. So this is going through a full example here. you will have to do something like this on your exam, so I recommend practicing. And then we'll have our answers in our part 5 video of inferential statistics. All right, thank you very much, and I will see you next week.